Today we're going to look at a simple introduction to probability. One really good way of looking at probability is to place the chance of something happening on a number line. And we basically go from impossible to certain. The number associated with impossible is 0, and the number associated with certain is 1. So that means the chance of something being equally likely, it can be written as a fraction, as a half, can be written as a percentage, 50% likely, 50% unlikely, or as a ratio. People often say chance of something happening is 50-50 or 1-to-1. Okay, I'm going to put a few of these things on a number line. So the chance of me eating pizza tomorrow, it's pretty unlikely, but who knows? So I'm going to put it there. I will roll a die and it will land on 8. Now a typical dice has 6 faces and it's numbered 1 to 6. So the chance of that dice landing on an 8 is actually 0, impossible. The chance of it raining tomorrow, well, here in England, that could happen. I've looked at the weather forecast and apparently it's somewhere between equally likely and certain, and I think that's around about 75%. Or 3/4. This one here, when I throw a coin, it will land on heads. So a coin has a tails and a heads. If it's a normal, unbiased coin, then it's equally likely to land on heads or tails. So the chance of it landing on heads is a half. The next pet I see will be a cat. Well, I have a dog. So the chances are most likely to see a dog, but occasionally a cat does go through our back garden. So it's not absolutely certain that the next pet I see will be a dog, but it's pretty likely. When I jump in the air, I will land back on the ground. Well, again, gravity pulls us back to Earth, so that's likely to happen. But then again, I could be jumping up onto a bench. So again, it depends what my situation is. It could be that I'm here. Well, in fact, it could be here. Next month is September. Well, this month is May, so the next month is June. So the chance of it being September next is impossible for me at this moment in time. I will roll a die and it will land on a 4. Now, I want to show how I'm going to write this. So the probability of it landing on a 4, there's 1 4 on a dice, on a normal dice. There are 6 faces, so the chance of it landing on a 4 is 1/6. I get every question right on this worksheet. Well, it depends on what the worksheet is like, but as I'm going to be doing some questions from a worksheet now for you guys, I'm hoping that the chance of me getting them correct is 100%. It's certain. Let's see. Okay, going to do each of these questions. And this is how I would like you to set out the work. So we've been asked to find the probability of the shaded counter each time. Okay, so I'm going to entitle that probability of S, the shaded counter. Okay, in A, how many counters are there? There are 4. Chance of it landing on a shaded counter is, or me picking a shaded counter is 3. 3 out of 4, 3/4. I could write that as 75% or 0.75. B, the probability of a shaded counter. Again, I can see there are 4 counters, and in fact there are 2 shaded ones, so the probability of a shaded counter is 2 out of 4. We can write that as a half. C, probability of a shaded counter. Well, I can see there are 5 counters, and 2 of them are shaded. I could write that as 4/10 or 0.4 if I wanted, or even 40%. D, probability of a shaded counter. I'm actually going to have to count these counters now. 1, 2, 3, 4, 5, 6, 7. There are 7 counters, and 1, 2, 3, 4 of them are shaded. So the probability of a shaded counter is 4/7. E, probability of a shaded counter. Well, how many are there in total? 1, 2, 3, 4, 5, 6, 7, 8. 8 possible outcomes, of which 5 are shaded. I can see that. And if I write that as a decimal, that is 0.625. F, probability of a shaded counter. Well, how many shaded are there? So how many in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many are shaded? 1, 2, 3, 4, 5, 6, 7. 7 tenths. G. Now I can see that all of the counters are shaded, so it's absolutely certain when I pick a counter that I will get a shaded one. When something is certain, it has an associated probability of 1. H. Probability of a shaded counter. How many counters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. How many are shaded? 1, 2, 3, 4, 4 ninths. I. Probability of a shaded counter. Now I can see that there are no shaded counters. The number associated when something is impossible as a probability is 0. And J, probability of a shaded counter. How many counters? I'm going to have to count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 counters in total. And how many are shaded? 1, 2, 3, 4, 5, 6. 6 15ths. I am going to simplify that by dividing by top and bottom by 3, which gives us 2/5. Okay. We're throwing a fair-sided dice now. A fair-sided, six-sided dice has 6 faces, and because it's fair, each face is equally likely to be face up. Okay, so probability of 5. There is only 1 5 out of 6 faces, so probability of getting a 5 is 1/6. Now the probability of an even number, well, the probability of an even number is the probability of getting a 2, a 4 and a 6. That is, 3 of the faces are even out of a possible 6, so that's 3/6, which is a half. The probability of an odd number, probability of odd, that's going to be 1, 3 and 5. Again, that is 1/2. D, probability of a prime number. Probability of a prime number. Okay, we just need to make sure we know what the prime numbers are. So 1, 2, 3, 4, 5, 6. 6 can't because it's even. 4 can't because it's even. The only prime number that is even is 2. 3 is a prime number because 1 and 3 are its only factors, and the same with 5. And just remembering that 1 isn't a prime number. So we have 3 out of a possible 6. Again, a half. E, probability of a square number. The probability of a square number, again, what are the square numbers? 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, but 9 doesn't fit onto the dice. So we are just looking for the probability of 1 and 4. There are 2 out of a possible 6 options. And F, probability of a number greater than 4. Now the trick here is to know that that doesn't include 4. So we are looking for the numbers 5 and 6. Probability of 5 and 6 is going to be 2 out of 6, which is 1/3.